here. So yeah, so what we're looking at right now in terms of our pacing is this week we're going to do parallelograms today, trapezoids tomorrow, and then your liftoff or legends of learning on Friday. Because we have map testing on Monday in math during this time. And then on Tuesday, I'm going to do one more day of practice of a bunch of different types of composite figures and stuff. Then Wednesday, I'm going to do a review of all the geometry type things we've done with this standard. And then Thursday, we're going to do a fairly significant quiz, because then we go into spring break on Friday. So I'm not actually, so next Wednesday, we'll do the review, and then you'll go right into whenever you're ready to do the quiz at that point. All right, so that is the kind of the plan here. All right, so parallelograms, I got us a couple of jokes here. The hardest shape to get out of is the trapezoid. You get it? Yeah, trapezoid, yeah. And then what do you call more than one L? Talking about parallelograms. It's para-L. Yeah, he took a pair of L's there. All right, so there you go. It's cheesy. All right, I think y'all know what all this stuff at this point. I did, wasn't here for target time yesterday. I did tell y'all that Monday and put it in my announcement. I'll be back as usual today and tomorrow if you need help on stuff. I think most of y'all kind of hit the stride of where to go for the help that you need and things like that. And I think that most people who have been engaged with this class and doing it for at least 9 weeks have been pretty well figuring out how to be pretty successful. What do you not get, Mary? The link? Oh, you don't get the joke. The parallels, right? Like parallelogram, like yeah, it's the parallels. Yeah, that's okay. Not important to get the joke. It's cool. So let's see. So far, you should be looking in your grade book for Unit 5 Quiz 2, Quiz 3, and Statistics and Review Quiz 1. And then we have another week of Liftoff Legends Learning this week, but there was one in there so far. And then several days of practice in Nearpods. I did catch, even though I was technically off yesterday, I did work like last night, last night, so that I'm not actually behind on grading. The grading was caught up as of what I saw at like 7 or 8 o'clock last night. So there we go. All right, so if you aren't logged in here yet, here is the login again, and we are going to get going on this. Okay, so today we're looking at things like the special quadrilaterals and polygons here. And so that's kind of what we're going to be looking at here. You can actually decompose and compose these as well. So using various strategies and formulas to find the areas of parallelograms and trapezoids. Okay. I personally just like to go ahead and solve them with formulas, but a lot of people prefer moving the shapes around. Okay. All right. So here's what we got here to start with. All right. So the first slide that you're doing here says A, B, and C on here are parallelograms. D, E, and F are not. Study the examples and the non-examples. Okay, so you need to write right here, what do you notice about the number of sides the parallelogram has? How many? And then that should say, for some reason, that copied over incorrectly. So there's nothing on that one. And what do you notice about the opposite angles of a parallelogram? It should be the opposite sides and the opposite angles, but it doesn't say that. So this is like, what do you notice about the opposite angles and sides? Okay, is really what I think I meant to put right there, and I didn't. Okay, so you got two things you need to answer there. So how many sides do they have? All right, and what's true about the opposite sides and angles? The opposite sides and angles, what's true of this? Chloe, it's the first and third one. The third one, is basically the second line was supposed to say, what do you notice about the opposite sides and then the opposite angles. Okay. All right. Oh, it did say it. Wait a second. Am I dumb? Yeah, not the number of sides. What? So it's like, I think I was meaning just to say that what was true about the sides. Okay. So what I want you to notice here, first of all, just on this slide, basic stuff. Four sides, right? And then the opposite sides are going to be parallel. Okay. And they're going to be the same. They're going to be congruent. All right. So therefore, what you'll notice about the opposite sides and angles is that they will be congruent or the same. So the word congruent is the fancy math word for exactly the same, right? So the opposite sides and angles are congruent. Okay. So that's the first thing here. Okay. This is kind of some definition stuff. All right. I'll move on in just a couple of seconds. Make sure you got it done. I'm sure you probably noticed by now, if you don't do these things, you don't get full credit. Okay. And this should be the easy points to get, right? Okay. I'll give you about 5 more seconds. Okay. All right. Now, so here's the deal with finding the area of a parallelogram. Okay. So there is a trick to this that will work. So if you'll notice right here, let's see, I got some, yeah. All right. So right here, if you'll notice, you see this part right here, like this triangle right here. If you cut that guy right there off and you move him over here, okay, then that would make this a rectangle. Okay. So basically, my drawing was horrible there. But the idea of this is if you move this one over here, let me try to do a little better this time. And you make this a rectangle that looks like this. That's the same thing. You just slid this over. So at this point, this becomes a rectangle that is 1, 2, 3, 4, 5, 6. 6 by 1, 2, 3, 4, 5, 6. So basically, the parallelogram, if it's the two sets parallel sides, still is going to work in a lot of ways the same as a rectangle to find the area. You just got to find the base times the height. Okay, so it's not super hard. Okay, all right. So, all right, now you do this one. Okay, so I would draw the lines to cut off one side. All right, the triangle. So cut off this triangle right here, like this. Then I would draw a line showing I was moving him over here. Okay. Like so. And then you say, okay, see, this is 2, that's 2. So it measures out the same. This is 1, 2, 3. That's 1, 2, 3. Measures out the same. So now we can find the area of this guy just by finding the area of this rectangle right here. That's all there is. Okay. So find your area, write your area right here. So it's, I see 3 here. 1, 2, 3, 4, 5 here. So you should be able to write down the area of the parallelogram. Okay, so go ahead and write your answer now. Because it's basically going to, once you move that triangle, it's going to be a rectangle, right? That's all there is to it. Don't overthink it. As long as you can do 3 times 5, you can do this answer. Somebody here put 4. That's not a 4 on the bottom. That's 3. Person right here. See it? This is a 3 right here. It's not that you're doing the thing wrong. You just counted the squares wrong. Okay. All right. So the area of this would be 15 square units, right? So 15 units square. Okay. So because it's just the 5 times the 3, right? 5 times 3. Simple enough, right? Okay. Now, Not all of them are going to be that easy though, but it's at least gives you an idea that this is really still base times height. Okay. Okay. Now, here's the thing here, and Chloe, I know this is what you were kind of telling me earlier. It's like, what, I got all these extra numbers, right? So what you don't need here, hopefully y'all can recognize, is this 4.5. Because to make this back to a rectangle shape, think about it. We're going to take this guy right here. We're going to move him over here. And then we're going to have a rectangle that's 6 times 4, right? Therefore, when you look at this slide right here, and it's just asking you for area, if it was asking for perimeter, we would need that, but we don't because it's area. Is you say, okay, I don't need the 4.5 because I just need the base here and the height here. Okay. So just notice what I'm saying there. You do not need the 4.5. So I would just mark it out because that's not the base or the height. Okay. So now you just need to find the area. Yeah, Gray?
If like whenever I'm drawing it, if it's not like if the triangle is really big and it doesn't
Yeah,
really
that's not
look
a
like
that's
that,
not a
is it
problem.
fine as long as I have the right numbers?
Yeah. Look, mine, you see mine's messy sometimes too. Okay.
Okay.
If you look at your grade book, you see that I have not been taking off points for what you've been doing on these. So I'm talking about the people who, like, I don't know what they're doing, but they mess around and only get a little bit of the slide done half the time. Like if it happens one time where it's like you were erasing and you were trying to finish it, I give the benefit of the doubt. What I'm not giving the benefit of the doubt for is people who do like this and just do that on a slide. You know what I mean? Like there's a few people in here that do that all the time. I take off the points all the time and they still do it. It doesn't make sense. All right. Yeah, Lorraine.
So, since we don't need the 45, I think it was. So do
Mm-hmm.
we just do 6 times 4?
Mm-hmm. Right. That's the whole thing that I'm trying to teach you here is that what it is basically this is a once you move this triangle over, it is a rectangle that is this times that. You see? So therefore, what I should see on your slide right now is once you've moved that, you should have the answer on here by now because I've been talking a while. So like half of you do. Okay, so what we're basically doing on this one is this base 6 times that height 4. So that's 24 square units. That's it. Ta-da. That was so hard, wasn't it? Man, that's impossible. Okay. All right. And questions on that one? Y'all are like, dude, that's so much easier than you would have thought it would have been, right? Like really not that hard. Okay. Okay. Now here's the deal is this, and I've already been kind of establishing this. The area of a parallelogram is the area equals the base times the height. Okay. The only issue for us is identifying what the base and the height are. Okay. If we do that correctly, we're just doing the same thing we do with a rectangle. Okay. So here is an example of correct bases and heights. So you see this one right here has a base. There's a height right there. Kind of the same idea with the triangle where it has to go perpendicular straight up and down and form the 90-degree angle. See right there? Now, could you, for example, could they have drawn this is the base right here? Yes, it could have. But if you do that, then the height has to be right there to make the right angle. See? Right. So it is depends on which one is the base as to which one the height's going to be. So like right here, as they said, as I was just saying, this is the base, then the height is there because it has to make that right angle. On this one, this is the base, the height is right there. What if they had drawn it right there? It doesn't matter. It's the same thing. Okay. Sometimes I'll even draw it outside of the parallelogram, like on this bottom right one over here. So you'll notice, okay, here's the base. The height is not there. No. It's got to be this, right? It's got to be this right here, the right angle, like so. Okay. So then that could have been drawn right here inside, like that. But that's the same number. It's not going to be any different. Okay. So any questions on that before we kind of go into some? I just wanted to show you several of those so you kind of see what we're working with. Okay. All right. So let's go to a couple of these. All right. Now, oh yeah, I remember what I was going to do next here. So what I want you to do on this one, it's a little bit different. I want you to correct where the height is based on the base they gave. Okay, so in other words, leaving this base right here, draw the height at the correct place. Okay, draw a height at a correct place for each one of these. For where they put the base, draw a correct height. Okay. With the little, you need to draw the little 90-degree box, the little box, right? So you're drawing little lines on each one of them. Okay, is what you're doing. So with the base that they have on there, you're drawing a little line on each one. All right. So let me show you my first one here. Maybe that'll give you an idea of what else you need to do here. Okay, so here's the way I would do this first one. So I'm going to draw, this is the base. That means the height's got to come straight down to the base right here to where it makes a 90-degree angle. So that's the height right there. Now, could you have drawn it right here? Yes. It just has to be a 90-degree angle to the base, right? And you show it's a 90-degree angle by drawing that little box down there in the corner. Okay? So you get the other three done. So this one, your base is right here. That means it's got to make a 90-degree angle from this. Okay? Get those drawn. And some of y'all not getting it. Some of you are. Again, it's got to be a right angle to the base, a 90-degree angle, like a T. Okay, you got to make a T with where it says base. That's all I'm wanting you to do here. Draw the little lines to make sure it makes a T shape from the base. Okay, some of y'all got this. Some of you is this particular part is not going to go well if you can't do that. Okay, so from this base right here, we need a 90-degree angle. So I'm going to draw it like this to show that that's 90 degrees. If you turn your head sideways, you can see that makes a T, right? Okay, from this one, I'm going to turn my head all the way sideways because I need this to go straight across like that as a T. You could have drawn it down here. Doesn't matter, but it needs to go straight into that base. Here, I need to go straight into this base like a T. So I'm going to start right here. I'm going to go at a 90-degree angle up to right there somewhere, right? So that is how long that height is, right? Okay, so this is the height on this one. Again, it could have come up here. That's fine, outside. But it has to be at a 90-degree angle to the base, wherever the base is labeled. Okay? So make yours look either like mine or, if you had it like, say, on this one, if it had been over here. As long as it's the 90-degree angle to the base, you're cool. Okay? All right. Any questions before we go on? Okay, moving on in about 5 seconds to make sure you got yours correctly labeled. Okay. All right. Now, there's 3 correct answers here. So check the ones you think are correct. See if you get the definition. Okay. So 3 of these 7 statements you should check. So only a horizontal side of a parallelogram can be a base, like only one that goes like this. Or is it B, any side of a parallelogram can be a base? C, a height can be drawn at any angle to the side chosen as the base. D, a base and its corresponding height must be perpendicular to each other, like a T, right angle. E, a height can only be drawn inside a parallelogram. Or F, a height can be drawn outside of the parallelogram as long as it's a 90-degree angle to the base. And G, a base cannot be extended to meet a height. Okay, so you need to pick 3 of those. See which 3 y'all got. Okay, I see. Oh, I see 2 people who are right so far. Three people right. This person's got 2 right. I just need to find 1 more. Remember, perpendicular means they're going to make a right angle, a 90-degree angle. Oh, 4 people are right. Okay. All right. Well, let's see what we got here. Okay. More people are right here. It's good. All right. So only a horizontal side can be a base. Wrong. We just went over that. Any side could be the base. Okay. Height can be drawn at any angle to the side chosen as the base. No, it has to be the right angle or perpendicular. Height can only be drawn inside a parallelogram. Nope. It can be drawn outside of it as long as it is at a 90-degree angle. The base could be extended to meet a height. That means on some of the other ones where it was like drawing the little line, dotted line outside. Yeah, you can do that. All right. So you need B, D, and F. Okay. B, D, and F. All right. Let me see here. Yeah, say just right. So B, D, and F is correct there. Okay. All right. Now, on this one, as you can probably see, what I'm concerned about on this is you knowing what the base and the height are. Because if you got the base and the height, you just multiply them, right? So your mistakes are going to come if you don't identify the correct base and height. So on this one, you need to, let's see, I see 1, 2, 3 that are correctly labeled. Okay. So you circle the 3 that are correctly labeled. All right, see how we're doing here. I see 1 person who's right. Nope. Hold up. Nope. Nope. Okay, so no there. So it's got to go from the base at a 90-degree angle to the height. Mm-hmm. Mm-hmm. I think some of y'all are saying why this is the big part of this, okay? Because if you get this part, the finding the actual area is easy after you find this part. Okay, I see 1 person who's correct. 2 people who are correct. I'm not gonna say yet. Nope, 3 people who are correct, 4 people who are correct. I see somebody who's got 2 of them correct and hasn't committed to the 3rd one. All right, so here we go. So this is why we're doing this is like, let's learn from our mistakes, right? So this first one, here's a base, there's a height. Does it go to a right angle, 90-degree angle with the base? Yes. Good. Okay, here's a base. This height, this one is like the big trick on this. It's going up and down. That doesn't make it the height. What makes it the height is if it is at a right angle with the base. That's the height of this parallelogram with this base being labeled this way. So that is wrong. No, 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 no. Okay, don't fall for that trick. All right, now, this is also not it. This is not it, base times height here. This height would have to be right here, like that, okay? Or it could be straight up and down right here. That is not straight up and down at a right angle. So that's no, no, no. Okay, now, this one, here's base. That height goes at a right angle. Yes, it can be outside. Because if you think about it, we could just draw that right here too. That would work. So that is correct. And then here, the base doesn't have to be on the bottom. Okay, get that. Here's the base. Is the height going at a perpendicular angle to the base? Yes, it is. Woohoo. Okay. So A, C, and D on that. Okay. Questions on that? Nobody see that? A, C, and D. Any questions? Fix yours if yours are wrong, please. And hopefully you can see that that really is the key thing here. Okay, guys, is that if you know, yeah, person here, you're wrong. Okay, so if I see it wrong when I go over like putting the grade in, you don't get a point for that slide because that ain't right. And I just literally went over. All right. So I mean, your loss. All right. So basically what I'm getting at is if I put the numbers on those and you know which ones are labeled correctly, you probably should be able to find the area. Okay. All right. In fact, I'm so confident in that that I didn't do any more like practice ones on here because you can do the practice to after class today with as long as you find the base and the height correctly, you're going to be fine. Okay, you just multiply the base times the height. All right, now trapezoids are quadrilaterals with one set of parallel sides. So this is tomorrow's practice. Okay, so the second part. So using the skills we've worked on, what you can do is you can cut one part of this off and flip it over and put it over here. Okay, so this is another one of those. All right, no way this actually works. Yes, it does. Watch. This guy right here, this triangle, is the same exact thing that is missing over here. Ta-da. See it? So that one right there, okay, this trapezoid right here, that's 1, 2, 3, 4 up here. And one, let me erase this so you can see what I'm talking about. Okay, so then down here, this is 1, 2, 3, 4, 5, 6, 7, 8, right? But if you chop this part off, notice this is not 8 over here anymore. We're going to flip this upside down and then slide it over here, there. So then now this is no longer 8 because that's not there anymore. Okay, this is 6, right? And then now this is 6 over here. So we took 2 of these over here, put them over there. So now it's 6 right there. And then the height is going to be 1, 2, 3. So that height didn't change. So the area of this trapezoid is 18. Okay. No, that's 6. Okay. So the trick to the trapezoid, all right, the general idea is this. Okay. So notice that this was, yeah, no. Okay. So this right here was 4 and this was 8. Notice that the average of 4 and 8, like the mean, is 6, right? So 4 plus 8, it's like this. 4 plus 8 divided by 2. So we're finding the average of these two. So that's 12 divided by 2 equals 6. So 6 is the average of these two bases. Then you multiply it by the height. Okay, so you average the two numbers that are the parallel sides, then you multiply by the height. That's how you do a trapezoid. Okay, so if it's one that you can't kind of deconstruct like that, that's the basics of it. Okay, all right, so, all right, I think I had the first one here. Yeah, okay, so I want you on this one, let's move this one. So deconstruct the trapezoid by making a rectangle that you move over. I mean, a triangle. Move this triangle over here. Then calculate the area as a rectangle. Okay. So same thing we were doing earlier. You're going to draw this guy off, move him over here, then figure out the area as a rectangle. Okay. Because this goes here. This is this point down here. Okay, so I'm going to go ahead and show drawing it over here. This guy goes over here. So he's going to end up looking like this right here. Here. Okay, so now, oops. So now I've got this side over here. Okay, so we're not using this part anymore. We got to imagine this now as being this rectangle right here that I'm outlining in red. Okay, so we moved that other part of that trapezoid over, flipped it upside down over here, and then it turned into a rectangle. So that's, hopefully you're getting ahead of me and you got the answer already. 4, 5, 6. You can look up here if you want to see what numbers you should be using to calculate with. Okay. See what you got for this trapezoid. Okay, some of y'all got it. Good. Person over here, the height is 4, not 5. Person over here, this is 4, not 5. Okay. So you're making a rectangle. This rectangle, once you move that triangle over, is 7 by 4. Therefore, the area equals 7 times 4, which is 28. Okay, now if you look at the original thing, the top was 4, right? And the bottom, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Was 4. The two bases were 4 and 10, right? So that's 14. We're averaging them. So the average of them is 7. That's also the same thing we saw when we moved it over here. So that's 7 times 4 is 28. Okay. Questions on that one? Okay. Now, okay. There might be something here that isn't entirely clear to me. But I would say, what I would say about one like this is still a trapezoid, okay? If you want to do this one by deconstructing it, what you do is you just do the rectangle and the triangle separately, okay? Then add them together. Now, what should be the case, though, all right, is that if you average these two bases right here, so let me show you what I'm talking about. If you take this one and this one, right, and you average those two, that would be 15, okay? I want you to see the shortcut here. The formula basically is average these two bases, okay? 15 is the average of 12 and 18. It's halfway in between. 12 plus 18 is 30, divided by 2 is 15. Then you multiply it times the height. This is the height, 8. So that's 120, okay? So that's how I can look at this, and I know that area just like that, okay? Now, if that doesn't click for you yet, here's how we do it. Yeah, Lorraine? Let me mute you. Where are you at? Yes.
Never mind. You answered it already.
Okay. Yeah, I'm not saying that you got to get it that way yet. I'm showing you that there's ways of doing this if you can't remember the formula, okay? So I'm just showing you that if you start to get this, then you can go ahead and look at it and say, okay, that's 12 and 18, average is 15. Here's the height, 15 times 8 is 120. It can get to where it's that fast, okay? All right, so let's do this one, kind of deconstructing it. So the first thing to do here on the rectangle part here, write the area of the rectangle right here, okay? So go ahead and write the area of the rectangle inside. All right. 12 times 8, if you don't know, 12 times 8 is 96. Okay. So I'm wanting you to do it deconstructed. Even if you can do it like I did it in your head, fine. We're going to do it deconstructed like this. Okay. So, right. So 96 here. I actually prefer when I've got an area like that, I like to circle it so I know it's not just another dimension. Okay. This letter A is just random, has nothing to do with it. Now we got to find the area of the triangle. Okay. So the area of the triangle is base times height divided by 2, right? So 6 times 8, as you should have already done in the practice yesterday, divided by 2. So that's 48 divided by 2, which is going to give us 24. Okay, so then this will be 24. So 96 and 24. So you can find all the shapes that we got to do here by doing rectangles and triangles. Okay, it's just that I'm showing you there's other kind of shortcuts if you like, oh yeah, I get it. Okay. So then you add these two together, 96 plus 24, right? Equals 120. All right. And then that would be square meters. Okay. All right. Yes.
So how did you get 96?
It's a, look, you see the rectangle right here? 12 times 8 right there.
So 12 times 8 is 96.
Yeah.
And so how did so you okay, so 12 times 8 is 96. So how did you get 6 times 8?
Right here. You see this? So this is the,
Okay.
ignore the rest of the problem now. Okay. So right here, if this was our only problem right here, okay, and we hadn't done that other part, and I give you a triangle that's 6 for the base and 8 for the height, right? See it? So you would
Yeah.
do 6 times 8, 48 divided by 2 is 24.
So you got the answer by multiplying 6 times 8 and then dividing the answer by 2.
Right, because triangles are half of rectangles. Yes.
Okay.
Yep. And that's it. So the key to this, if you want to do it by deconstructing, is just seeing what shapes you have. Okay.
Okay.
So there's the cool thing about this standard and the way it's written in South Carolina is you can do it several different ways and be right. So unlike on the equations when I was telling y'all, you got to show it this way or I got to take all points. On this, as long as you show work, it's going to be fine. You just got to show it one way or the other, right? Okay. Okay, so now this one, I put this one on here because there's a little something missing, okay? So the first thing you need to do on this one is you need to do something that's not there. So you see this right here is not there. Okay, be really careful here. Here's what you're going to make a mistake on if you do make a mistake. This 8 right here, we only need to find this amount right here. So the key of this problem is seeing that this is 5, this whole thing is 8. Therefore, this little amount right here, the part that is from right here over, right? Just this little part right here, that has to be 3. Okay. Let me kind of show you why. Okay, so I'm marking out that 8 so you can see it. If this is 5 right here, and this is a rectangle, right? That means this is 5 right here. 5 plus 3 together makes the whole 8 right there. Okay. Any questions on that? I think that it is very important that you're very, very careful in getting these labels correct. Okay, that's where you're going to make the mistakes. Okay, so now this is a 5 by 4 rectangle. Then this is a triangle that's 3 by 4. This 5 right here is a waste of your time. I would mark it out. It's just going to confuse you. Okay, once we get to here, now we should be able to find the area with very little trouble. Okay, so go ahead and put the area here, here, and then put the answer. Okay. So you got a rectangle, you got a triangle, and then you got them added together. Okay, right here, person right here, you're wrong because you don't have the correct height. This guy right here, do not use him. Look, this is the height of the triangle right here. See that 4 right there. So 3 times 4 divided by 2. That's your mistake. Okay, those of you who are getting 7.5 on the triangle, you're wrong. Watch why. This 5 is not the height of the triangle. The height of the triangle is coming straight down with the base right here. See it? So the height of the triangle is this 4 right here. This is why it's essential that we get this problem right now. Okay? See that this has to come down and do the perpendicular thing where it makes the T into this base right here. See it? Right there. That 5 is not the height of the triangle. The height of the triangle has to be perpendicular to the base. I've said that like 25 million times, I feel like. Okay. So therefore, everybody's getting this rectangle is 20. What I'm really worried about is either you're going to miss this one right here, or you're going to miss that height right there. So this is 3 times 4, right? Which is 12. Okay. And then 12 divided by 2 is 6. Okay. Therefore, the answer of the whole thing is going to be 20 plus 6, which is 26 square meters. Okay. Everybody see what I did there? So 7.5 person here, you need to change that. It's not 7.5. Okay. There's still 3 of you that have 7.5 on there. You need to fix it. Quit taking a nap and fix your work. Okay. Whatever you're doing. Okay. It is not 7.5. Yo, right here, not 7.5. That's wrong because this is 4 right here. This 5 has nothing to do with this problem. No, no, no. Okay, this is 3 times 4 is 12, divided by 2 is 6. So 20 plus 6 is 26. Okay. And let's see who else I need to mark on here. That's like super important that you don't miss that here. Okay. Right here. Wrong. If this is 4, okay, and this is 3 down here, because that's 5 and that's 8. 4 times 3 is 12, divided by 2 is 6. Right here. Okay, so here's what the work should look like. You got a 6 right here for this triangle and a 20 for that rectangle. Okay. Okay, any questions on that? Okay. All right, we got 2 more slides here. All right, so here is the trapezoid formula. Okay. And I already said this, but I want you to see what the formula looks like. You take the average of the 2 bases, right? This one plus this one divided by 2. Okay. I showed you that on several of them, right? What the average of the 2 was. Then you multiply it times the height. Basically is what you're doing with the trapezoid. So we looked at that by moving the little triangles over, and then we looked at it by kind of dividing, separating them off. Either way you look at it, what the one thing that's true of all of the trapezoids is that you can average the bases and multiply it times the height. Okay, so that is very helpful on ones like this. Okay, so for example, on this one right here, and this is the last slide we're going to do together, but this one's really important because I got some like this on our practice tomorrow and on the quiz next week. Okay, so you have a trapezoid. So you need to average the 2 bases and then multiply times the height. What I would do is I would draw draw it anyway. Okay, so I would do like this. So you got the parallel bases. Yours are probably better than mine, but here's 11, here's 9, and then the height is going to be 8. Okay, so now what you do here is you average the 2 bases. I actually like doing it this way. I think it's easier. So I take the 9 plus 11. Okay, that's 20. So then I divide it by 2. All right, and that's going to be 10. Now what that is that I took the average of the bases, which is 10, and now I do it times the height. So the average of the bases is 10 times the height, which is 8, meaning the area is 80 square inches. Okay, 80 square inches. Okay. Now, you could do like this is 1 over here and move it over there, but it's not going to all be labeled like that all the time. Okay. So here's another one like this. Okay. So you could take, for example, this right here, and you got, okay, this is 10, that's 6. That means this has to be 6 right over here. So that makes this one 60. Okay. Now, if I do that though, I got to know that this is 10. Well, how much is this side over here? Well, if this is 6 right here, that leaves 14. So that would be 7 and 7, right? Because you got to take what's left over and divide it by 2. That to me is a bit harder than just doing it with the average of the two bases. Okay, so what I would do on one like this is the following. Okay, I want to take the base 1 and the base 2. So 6 plus 20. I want to average them, finding the mean. 6 plus 20 divided by 2. So halfway between 6 and 20. So that's going to be 26 divided by 2, which is going to be 13. Okay. Now, that's the average of the bases. So 13, then times the height, times the height, which is going to give us 130. Okay. So if you average the bases, the two that are the parallel sides, right, on a trapezoid, you average them like this. That's the average of the bases right there. Once you average them, you multiply it by the height, because then you'd use the same formula as a rectangle. 13 times 10 is 130. That is the final answer on that. Okay. All right. Questions on that before we close out here? Make sure you got that 130 on there and the 80 on that first one. Okay. So 80 on the first one and 130 on the second one, and tell me if there's anything that's confusing you on that. I think that when they get to be these funny shaped trapezoids like this, it's better to understand the formula where you average the two bases and then multiply by the height. I think that's a very useful skill, as opposed to having to cut off a bunch of triangles and do the rectangle in the middle. It's doable that way. It is, but I think it's probably a bit harder. Okay. So kind of wrap that up here. Yeah, Gray, you're good on the second one. Go back and put the first one, the how we would get that first one there to get to that 80, okay? All right, so I'm going to go to the last slide, and then I'll come back for people that need to finish up this one. Okay, so basically today you got the area of parallelograms. Tomorrow's the trapezoids. Friday is your liftoff for Legends of Learning. No quiz this week. We're going to quiz this next Thursday. And absolutely, you want to make sure that you watch the videos going over this so you can hear my explanation of how I do each one of these. So if you're stuck on something, don't turn it in wrong or just not turn it in. Go watch me explain it, learn from that, turn it in, and then ask me if you got any questions, okay? All right, so kind of wrapping it up here. If you need more time finishing up this slide, go ahead and fix that one. And then if you need me to go back to any other slides, then I certainly can do so as well. Okay. All right. If you're done, then you can go.